Patty, can you tell me about your project?
We were creating a robot for the Mate ROV challenge, and so our robot, which is not here right now because they had to go to the dive, is a steel frame with motors that are set at 45-degree angles so that we can strafe, go forward. We have the full power in the four directions so that whenever we're moving, we can use the full power of all the motors. And we have the payload tools necessary to be able to complete the 4 tasks that we were assigned to identify all of the damage marks on the submarine, pick up the airline and put it into the airline to open the valve and then close it, put the pods with the life support stuff into the hatch after opening the hatch, and putting the mating skirt that we had to attach to our robot on top of the identified area in order to be able to pull the people that would be in the submarine out of the submarine into the ROV. And so in order to accomplish this at our school, we, the robotics club from HighTech, did a series of research and construction and testing. And in the beginning, we separated into a bunch of different groups to research all the possible things that we would have to work on for our robot. We had a group researching cameras, a group researching propellers and propulsion. We had a group researching materials to use for the frame. We had a group researching stuff that we had to use for the tether to get the power down to the robot. And with all this research, then we came together and we brainstormed ideas for what we wanted our robot to look like. And we came up with a rectangular frame made out of 1/4-inch steel that we could attach motors to easily, and pretty much everything on our robot ended up being movable, and so that we could make adjustments as needed. And
what were some of the challenges that you folks encountered in the project?
One of the biggest challenges we encountered was with the electronics box, because getting electronics wet doesn't really work too well with anything. So our biggest challenge was every time we would test the box, it would leak. So what we would do is, it took 2 weeks to actually fully waterproof the box, because it takes 24 hours for the silicone to dry, and then you put it in and you pull it out and you see if the paper towels are wet after a couple hours, and if it's wet then you have to do it all over again, so you'd have to wait another 24 to 48 hours before actually doing anything again. So that was one of the biggest challenges. Other challenges we encountered was like finding the right kind of cameras, how to seal them, you know.
And you haven't done this project before, or have you?
We did it 4 years ago. Well, yeah.
I think it's
like 4 years ago.
3.
We did it twice.
because current seniors on our team were part of this project in their freshman year.
Right.
Okay. So are any of you here seniors?
No.
Okay. So for all of you, you're new to the project. And
Yes.
how was that coming into what looks like a wickedly complex project and figuring it out?
It was hard at first. Like we weren't really sure what we were doing, but we did have some experience because people who did it in the past, like the seniors from the last time they did it, came in and talked to us about what they did. They gave us advice. They helped us design what we were doing in the early stages. But after that, it was pretty much up to us. It was up to us to build the robot. So.
And there was no plan for the robot provided by anybody else.
All the plans we came up with.
And how was that process of figuring out what you were going to do?
Somewhat tedious. We spent a lot of time researching.
At least a month and a half.
Yeah, we just met after school in an after-school lab. If our advisor had to be down in the tech lab for the scheduled lab, we met in a different room with another teacher, and we researched a lot.
And did the adults tell you how to do it?
The club advisor, she really sat back and let the kids take control of the project, because she didn't really want to be, she wanted to let us figure it out, you know, so we could actually learn something. So she was really helpful in that sense.
Her main role as the advisor was to give us access to the school's tech lab, and also to make sure nobody got hurt working on the robot, and to just deal with like the logistics of getting here and the trip and whatnot with the district. But all the actual design and the robot itself was entirely done by the team.
And as a group of high school students, how were you able to kind of get along well enough to get something done?
Well, our school is a public, selective admissions public school. So what that is, like, you have to take a test to get in. So with that in mind, everyone in the school is very similar. So everyone can really get along really well. And so it's not that hard to get along with anyone. There isn't a really, like in average high schools, there's a huge boundary between a freshman and a senior, or, you know, the class differences. But in our school, it's really well meshed together.
Plus our school is a rather small school. Our grade has about 60 people. The school has about 260. So most of us know pretty much everyone in the school. So no one is really strangers around in our school.
And you'll do the project again next year?
Absolutely.
Most definitely.
And right now people are doing a wet test on the robot?
Yeah.
We're doing the safety check before we can go into the water, which we are scheduled to go into the water at 11:30.
Great. Well, good luck.
Thank you.
Thank you.